We've got a doctor uses an intravenous drip to deliver fluids and medications to patients. Suppose an IV drip starts with 1,000 milliliters of saline and then dispenses fluid at a rate of 2.5 milliliters per minute. And so I'm looking at this and saying, okay, I start with this much and I'm dispensing fluid. So that means giving it out. So this rate is really a negative. And that's the hardest thing, I think, to realize about this problem up front. So let me write some stuff down on paper. All right, so again, if this were a test on paper, I would expect to see this is number 5. Number 5, we've got IV drip. And so it's always a good idea to write a summary of what you read to help your mind, get its stuff together to do the right thing. So IV drip, that's important, that it starts with 1,000 milliliters. And then they said dispenses at a rate. And sometimes I just rewrite exactly what they said. Sometimes I reword it. Dispenses at a rate of 2.5 milliliters per what? Milliliters per minute. Okay. And rate, once I see something like rate in my head, I think slope, because slope is also called a rate of change. And then the other important thing I mentioned a minute ago is the idea of dispenses, right? That means gives away. And if you give away something, you lose it. So that's negative. This starting at y-intercepts are where we start. So this must be my y-intercept. So whenever I have a problem that's new to me and I'm trying to figure out what the heck to do with it, just reading it isn't enough. I got to read it several times, take some notes on it, and try and relate it to stuff that I know. And here, let's see if I read the next question. It says, write an equation using F to represent the amount of fluid, left in milliliters, T to represent the time. Hint, if you have trouble writing a model, try making a table first. Okay, so I could try making a table too. A spreadsheet's a great way to do that. And then what kind of model is this? Well, based on the fact that they said a rate here, I'm guessing it's a linear model. And so that should be one of the options here. Is this linear? Yes, because they gave me the rate there. Okay, so then I think, all right, linear means it's got to be a y equals mx plus b type thing. And I think I've identified m here. And I think I've identified b up there. So I think it's y equals negative 2.5 x plus 1,000. And then I should check what variables they want me to use. F for fluid, okay, I'm using y, so I'll have to switch that, and then T for time in minutes. Okay, so let's fix that. So they want it as F equals negative 2.5 T plus 1,000. And then on my paper, I usually like to remind myself S is the amount of fluid in milliliters. That's an L, believe it or not. And T is minutes gone by. I'm just going to call it minutes. And there's my formula that I can play with there. So what else do we got here? F. And a lot of times when you click there, it'll give you hints like what letters to use. So if you're typing Y and X and it says F and T, you better reread and double check. Negative 2.5 T plus 1,000. So too many zeros, that's better. Okay, that looks good. Is it linear? Yes. Because my answer would be the slope is the rate minutes of change of negative 2.5 milliliters per minute, right? So I can see a slope, so that's why I think it's linear, and there's many other answers you could put there. Let's see, and again, if we weren't sure, it said make a table. Oh, let's make a table, kind of curious about that. So let's make a new sheet down here. Let's call this one number 5. And then here I have minutes. There we go. And IV fluid. And at 0, I start with 1,000. And then it said for every minute that goes by, drop that by 2.5. So I could just go equals, take the number above, minus 2.5. We did something like this way back in the first week of classes on a spreadsheet, but it's been a while. So after 1 minute, there's that much. After 2 minutes, I just drop that again by 2.5. So I can just go equals, take the number above, minus 2.5 again. And if I just keep going every 1 minute at a time, this is just going to keep dropping over and over again. And so once I have this pattern there of 2 sets of numbers, I can just fill it down. And it turns out you can fill them together if you grab 2 of them like that. And I can just fill it down for a while. And then if I graph this by highlighting it, insert chart, that looks like a pretty straight line there. Okay, so it turns out the spreadsheet can help with the table here if you know how to plug it in. And so that's a trick on how to do this one, given that change of 2.5 milliliters per minute. All right, so how long will it take to use all the saline? Okay, I could keep filling down on my spreadsheet till I get to no more milliliters, or I could solve the equation. I want to know when the fluid is gone. So when is it empty? When is it 0? And that uses all of the saline. So let's try it. So we've got that equation there. We're then asked, when is the fluid gone? And then I have to realize that that means the fluid is 0, right? Gone. So I put a 0 for F and solve. So new page, 0 equals negative 2.5 times T plus 1,000. And we've solved equations like this before. The first step is to get rid of what's added and subtracted. Since it's a plus, I'm going to do a minus. 0 minus 1,000 is minus 1,000. And that's gone over there, and I just have negative 2.5t. And then to get rid of that multiplication, we're going to divide by negative 2.5. Negative divided by negative is a positive. That's a good thing. And so I just need to figure out what is 1,000 by 2.5. 400. 400 what? Good question. I don't know. T is 400. And let's see, what did I write down? What does T mean? T is minutes, okay. So 400 minutes. 400 minutes for what? And 400 minutes. IV bag will be empty. Not a great sentence, but good enough for now. All right, so that came out nice. If there's some decimal amount, I would round it. And did they tell me any rounding instructions here? Oh, they want hours and minutes here. Oh, 400 minutes is how many hours? Okay, here we have fun. Let's see. I have an answer of 400 minutes. And let's see, I know that there's 60 minutes in 1 hour. And so to get rid of the minutes, I'm going to divide. And if you're not sure about multiplying or dividing when you're converting, just think about multiplying by a fraction. To get rid of minutes, it would be in the bottom. Hours goes in the top. And so there's 60 minutes in 1 hour. So the division by 60. So I need to know what is 400 over 60. Calculator. Divide by 60. Well, 6 hours, and then that's not minutes, that's a decimal. That's like 66 hundredths, not minutes are out of 60s. So then I have to figure, okay, 0.66 is what part of an hour? So there's a couple ways to think about that. So I'm just gonna write down my first result, that this equals 6.6666, a whole bunch of sixes, and eventually the calculator ran out of room and said 7. So that's just hours, no more minutes. The other way to do it is to actually like do long division. Take 60 into 400, because then we're going to get a remainder. And let's see, 60 goes into 400. Well, up here it says 6 times. What's 6 times 60? 6 times 60 is 360. So 60 goes into 400 6 times. 6 times 60 is 360. Subtract, and that gives me what? 40 remainder. So this remainder here is the number of extra minutes. Just to check, if you took 40 divided by 60, you should get that 0.66666. So I would say then 6 hours and 40 minutes. Whipping out with long division to figure out what the remainder is one way to come up with the number of minutes. Here's another cute way to do it. On my calculator, I had 400 divided by 60, and then I had this decimal I wasn't sure to do with. But the cool thing is I know that 6 is the 6 hours, so I'm just going to get rid of it, minus that 6. Now I need to know what fraction of an hour is this. Well, to get here, I divided by 60. So to get back, I just multiply that fraction by 60. And the calculator says, oh, okay, 40 was what that remainder was. So to get that decimal, I had divided by 60. So I remove the whole number, multiply the 60 back in, and that gives me the remainder, 40 minutes. Okay. 6 hours. 40 minutes. Which of the following can be used to describe the point you found? Horizontal intercept, vertical intercept, slope, or rate of change. Now, I started looking at the graph of that here, and it looks like, that graph go? It's down here. Yeah. Notice it's dropping down, right? And what we were asked is basically, when does this go to nothing down at the bottom here? When is there no more fluid? So that would be the horizontal intercept that we were looking for. When does that drop to nothing? So that would be horizontal intercept. Woohoo.